Okay, I think I'm live now. Can someone confirm if I'm live? I solved two questions, but in each question I got 60-second test case wrong. I think I'm not made for. If you're able to do like eighth question and like you're getting 60-second test case, then I think like you should. The only thing you need is practice. That's it. I'll solve two questions, but not get rank up to 8,000 practice. Okay, am I live? I don't have any yes or no's yet. There's some lag. Oh, yeah, only one question new in CP. Yes, so Joel says yes. Okay, perfect, perfect. All right. Okay, so we are going to solve Codeforces round 781 today. It's a Div-2 round, and we will be doing A, B, and C, and we might also solve like D also. Like I know my solution is correct, but I'm getting wrong answer on test case one only for the second input. Yeah, any idea about problem C level? Problem C was an easy problem, although I also got wrong answer in system testing. I got wrong answer on 20th test case. But yeah, C was a little bit tricky question. Okay. Okay, should we start now? We only have 19 people watching. Why is that? And only 9 likes. Why? Okay, let's wait for a minute or two. We'll definitely be doing A, B, and C. We might also solve D. Is the editorial available? Problem D. No. Oh, it's for edu. Yeah, editorial is also available. Okay, cool. Were you using priority queue in C? I don't remember what I used. Just a second. Oh, tree infection. No, I just sorted. I didn't use any priority queue. Okay. Okay, I think we should start now. Any advice for learning DP? Try CSS problem set. Okay, I'll start with the very first problem and we'll go in order as always. Okay, cool. Solved ABC but did C very late, so 2000 rank. Oh, that's good. Like at least you were able to solve C. My C got wrong answer. Right? Okay, let's start with problem E now. Problem A now. You're given a positive integer n. You have to find 4 positive integers A, B, C, and D such that A plus B plus C plus D equals to n. So we have a n. We need to find 4 positive integers such that A plus B plus C plus D is equals to n. Okay, and GCD of A comma B should be equal to LCM of C comma D. Okay, so I'm pretty sure like problem was clear to everyone. Now, if you see GCD of any number with 1 is 1, and it is actually given in the constraints only that what n is greater than 4. So that's a direct hint that you can assume A equals to n minus 3, B equals to 1, C equals to 1, and D equals to 1. Now your GCD of n minus 3 comma 1 is going to be 1, and your LCM of 1 comma 1 is also 1. Okay, so that's all you had to do for problem A. I'll quickly show my code. So yeah, I just printed x minus 3 1 1 1. That's it. Okay, cool. Okay, let's move on to problem B now. Cool. Now for problem B, you're given an array A of n integers. Initially there is only one copy of the given array. You can do operations of two types. Choose any array and clone it. After that, there is one more copy of that chosen array. Swap two elements from any two copies on any positions. You need to find the minimum number of operations needed to obtain a copy where all elements are equal. Okay, so let's look at what the second test case, and I'll show you the solution also through the test case. Okay, so what we have is we have 0 1 3370. Okay, now in one operation you can either clone this complete array or you can swap any two elements. Okay, so we know that like since 3 is 2 times, it is pretty sure that we need to make an array which has all the 3's. Okay, now for the very first arrays there is no other option than to clone. Okay, so we clone it and we get 1013370. Now we have two more 3's. So let's swap these elements. So let's say this 3 and this 3 is swapped with this 7 first. This 3 is swapped with this 7. So 3 and 7 comes here. And then this 3 also goes and we get a 0 here and 3 here. Now since this has 4 3's, we can actually clone this one again. So we have, okay, the operations till now done are 1 plus 1 plus 1. 1 was for cloning and 2 were for swapping. Then we have 1, again cloning 0, 1, 3, 3, 3, 3. Okay, so plus 1 for operations. Okay, and now you need to fill these two positions also with 3. So take this 3, fill it here. So we have 0 here, 3 here, and then again 1 here and 3 here. So two more operations, plus 1, and we need to make 6 operations. And as you can see in the input also, the answer for this one is actually 3. So how to do this? The first thing that you have to do was find the max element. Okay, find the count of max element. So you need to find count of the max element first. Okay, so when you have count of the maximum element, okay, now you need to find how many more positions you need to fill. Okay, then what you need to do is first clone the array. Okay, clone the array, fill count max positions from this. Okay, so basically what you have is if you find count max, this is the count of the element which is maximum number of times. Now subtract this within, this is the number of more positions you need to fill with the maximum element. Okay, now what you do is first you make one operation for cloning, then you do what, count max operations, through which this value becomes subtracted by count max. Now again what you do is again clone, but if you see, now your array has 2 times count max, because initially it has 2 3's only, but when you did these count max operations, your array now had 4 3's. So the next time you do this will be 2 times count max. Again plus 2 times count max. Okay, so basically what you have to do is the number of swappings that you need to do is this only, because these are the rest of the positions. Okay, and now you just need to make sure that how many times do I need to clone this array so that this count is greater than n. That's it. Okay, so I'll quickly show my code as well, and with that, like, it will become very easier to see. So basically what I'm actually doing is, first I have a map m, and in this map I'm storing the count of all the elements. Okay, and then in this maxi I'm trying to find out which value has its count as maximum. So this maxi actually stores the count of the maximum element. Okay, the element which has the highest number of occurrences. Okay, now n minus maxi is the number of positions we need to swap. Okay, now this count is also maxi. Okay, now while this count is less than n. Okay, because initially, sorry, this count is actually count max only. Okay, and we actually need to make sure that this becomes equals to 0. Okay, so initially in the very first array you had count max element, next time you had 2 times count max, next time you'll have 4 times count max, and so on. Okay, and the number of times you do this operations, you'll multiply count by 2, because that is the number of operations you are doing. Okay, and that's it. Then in the end you just print the answer. Is this clear? Zoom. Just a sec. Okay, is this better? What is the meaning of hack in Codeforces? Hack actually me. Okay, I'll tell this after this problem. Silly count mistake की वजह से B क्वेश्चन में 20 मिनट रह गए. Okay, is B problem B clear to everyone? Y was initialized to n minus, Y answer was initialized to n minus maxi. Because this is the initial number. Okay, so these are the total number of swaps you need. Okay, that's why. Because like in this, these four positions, these two positions were not four, were not three. Therefore, these are the total number of swaps you need to find out. Okay, now you just need to find, this is maxi. Okay, how many more operations you need to do, such like cloning operations you need to do, such that the total number of threes you have is greater than n, and that's it. Okay, first answer. Okay, I think this is also clear to everyone. This also again a little tricky, but yeah. Okay, cool. I think we can move on to problem C now. Okay, cool. Got it. Thanks. Okay, infection. Okay. Okay, I need to zoom out now. Going. Oh, yeah, I have done silly mistake in B due to which I lost my 60 points. Can you help me how to avoid these kind of mistakes? Just practice, that's it. Okay, cool. A tree is a connected graph with okay, this is just the definition of a tree. We're given a rooted tree with n vertices. The vertex 1 is a root. Initially, all vertices are healthy. Each second, you do two operations, the spreading operation and after that, the injection operation. Spreading for each vertex V, if at least one child of V is infected, you can spread the disease by infecting at most one other child of your V of your choice. Injection, you can choose any healthy vertex and inject it. Okay. So, okay, I'll explain from this only. Or I can actually make this. Okay, it's better. So we had a tree and this tree was something like this. Okay, now 5, 6 and 7. Okay, so this was the initial tree that we had. Okay, and in one operation we can actually select any vertex and make it what? Infectious. That's, yeah, and we can just spread the infection into it. Or what we can do is, and what we can do is, if a parent has one of its children as infected, one other children can also be infected through that. So basically, for example, let's say that at t equals to 0, at t equals to 0, or t equals to 1 actually, at t equals to 1, we infected 2. So this 2 is infected now. Okay. And since no other child was infected already, the no other child gets communicable. Okay. Then at t equals to 2, let's say, okay, before doing an infection, we see that one has a child 2 which is already infected. So what we can do is, let's say that 3 also got infected because of 2. Let's say this also got infected. And now we have one infection operation also. So let's say we infected 5. So we infected 5 at t equals to 2. Now at t equals to 3, we'll say that since one had 2 children who were infected, we can say that 4 also got infected. And similarly, since 2 had 2 children, 5 and 6, and 5 was infected, therefore we can say that 6 is also infected. Okay. And what we can also do is, we can infect 7 because we had one infection operation also. So let's say we infected 7. Now in the next case, when t becomes equals to 4, now only 1 is left, and since 1 has no other sibling which is infected, therefore it cannot be infected. But we can directly put an infection into it, so 1 gets infected. So basically at t equals to 4, all the values were infected. Therefore the answer for this one becomes 4. Now how to do this? Okay, I'm able to do A and B, not C. Okay, that's okay. Like basically, like there is a gap between B and C, good gap between B and C, which actually gets covered using doing practice. Okay, so I actually also got wrong answer on test case 20 in this one. Okay, so but yeah, I know the solution. Like, okay, so what we can do is, let's say, let's try to make a tree. Let's say this was the root. and it had many number of children. Okay, then one of these children had again many number of children, then again one other children had many children, and so on. Let's say after this also had many children, this also had many children, and so on. Let's say the number of elements in this set, like the number of children of the root be what? A1. Let's say the number of children of this be A2, like the count of number of children of this value be A2. So basically in this set there are A2 nodes. Let this be A3, let this be A4, let this be A5. And since root is also a child, actually, like root is also a child of what? Of something, or -1, let's say. So we need to consider this as a set also. So let's say we took all these values, like the total number of elements in every set, and we put them in a vector. Okay, so let's say we have A1, A2, A3, and A4 only. Okay, let's remove, like, let's forget A5 and the root, okay, for now. Let's say this vector contains size of all these sets. And then let's say we sort them in reverse order such that A1 is the largest value. Okay, now the very first thing that you can see is it is always beneficial to infect the set with the maximum count in the very first try, because after that when we're infecting all the other sets, this actually gets the infection in this set keeps on spreading. Okay, so it is always beneficial, okay, to infect the set with the highest count, so that after that whenever you're infecting other sets, like the previous sets keep on spreading. Okay, now we are done with this. Okay, so we have A1, A2, A3, A4, and let's say we fix a number. Let's say we fix a number X. Okay, and we try to see, is it possible that in t equals to X all the values are infected? Okay, now to do that, how can we make sure that A1 is infected? Okay, now if you see, the indexes are 0, 1, 2, and 3. And let's say we first infect this one, then this one, then this one, and then this one. So we know that A1 gets infected at t equals to 0. Set A1 gets infected at t equals to 0. A2 gets infected at t equals to 1. A3 gets infected at t equals to 2. And A4 gets infected at t equals to 3. Okay. And after that, we need to like find some way such that like all the elements get infected. Okay. Because first we infect 1, 1 values from every set. Okay. First we infect 1, 1 value from every set, and then we leave them for spreading. Okay, but we can also infect after that also, so we need to optimize those operations also. Now how to do that? Let's say we are trying to see if at t equals to X were we able to infect all the people. Okay, now in order to do that, we know that A1 was infected at 0th second. Okay, so what is, okay, so we had A1 number of values. Okay, and how many, let's say that we only had one set, and which was A1. How many seconds are needed to infect this complete set? Okay, let's say we had what? A1 equals to 3 only. Let's say we had A1 equals to 3, which means let's say we had like these three values, these three children. How much time was required to infect this complete set? The very first term, we would infect one value. The next term, we would assume that this is spreading. And in the next second also, we'll assume that this is spreading. Okay. So basically in t equals to 3 seconds, this complete set will become infected if only one was infected in the very first try. Okay, so basically if there is a set with size A1, okay, and if we infect only one child in this at t equals to 1, then A1 seconds are required for the virus to spread in this one. Okay, so for this A1 seconds are required. Now, how many seconds are required for this A2? For this A2 minus 1 seconds are required. Sorry, plus 1 seconds. Plus 1 second. Because this got start like after 1 second, this we infected the one child from this one. Okay. Similarly, A3 plus 2 and A4 plus 3. which is actually a of I plus I. Okay. Now, how many total seconds do we have? We have X number of seconds. So, if we subtract X, and let's say the value left after this was count. Okay, so this is the like values left after X seconds. Similarly for others also. Okay, so we can actually write this also. Let's say A1 plus 0, sorry, A0 plus 0, A1 plus 1 minus X. This is count 1, this is count 2, then count 3 will be A2 plus 2 minus X, and then for A3 minus 3, sorry, A3 plus 3 minus X, this is count 4. These are the elements which are left. This is the count of elements which are still not infected. And we need to infect these values. Okay. Now, how many? Okay, so we had two operations, spread and infect. And if we are doing X number of, if we are taking X number of seconds, okay, we have already done spreading once. Okay, so basically in this, we are assuming that like what? How many operations are used for spreading? Like A1 minus X operations are used for spreading. Similarly, in this, these values are used for spreading. These values are so basic. Yeah, okay. How many infections have we done? In this set, one infection was done. In this set, one infection was done. In this set, one infection was done. And in this set, one infection was done. So in total, a size. Okay, let's write size only. The size of this set. The number of operations done for this were the size of this set, because for every set we are doing one operation. Okay, one infection. So how many infections are left? We had X seconds, therefore we could do X infections. So X minus size operations are left. And how many values are left which we need to like infect? These are this. If the X minus size is greater than equal to the sum of these four values, then we can say that in X seconds everybody is infected. Is this clear? A little difficult to understand. I'll explain again. So if we infected A1, this A1 set at the very first second, how many seconds are required for this set to spread, for the virus to spread in the complete set? It is A1, because in the first second we infected, and then in the A1 minus 1 seconds spreading was done. So in total A1 seconds were required for the virus to spread. Similarly for this, A2 plus 1 were required, because this 1 second is actually because this 1 second was wasted on this one. So nothing was done in this set. So A2 plus 1. Similarly for A3, it is A3 plus 2, because 2 seconds were wasted for these two sets, and so on. Okay. Now, for the very first set, if you see, we only had X number of operations, X time. Okay. But this needed A1 time. Okay. So if we subtract, like, not A1, like A1 only, let's say A0. If we subtract A0 minus X, then we get how many values in this set are still infected, like not infected. Similarly for the second set also, count 2 is the count of all the values which are not infected. Similarly count 3 and count 4. Now we need to infect all these people. To infect all these people, we need to see how many infection operations are still left with us. We already did the size of this complete vector infection operations, because for every set we did one operation. So size, and we could do X infections. So X minus size is the total number of infections left. So if this value is greater than this count, sum of count, then we can say in X seconds we will be able to infect all the people using infection and spreading. And for this X, you can just run a binary search. So okay, I'll show the code also. Okay, my code is a greedy code and it got wrong answer on test case 20. So I'll show you somebody else's code. So you okay, so let's see. This is kind of similar only. What, so basically what this person is saying is that So first he's finding the degree of every root. Okay, this degree actually tells how many children a value has. So like if you scanned x, that means ith index had x as a child. So degree of x is increased. So basically, and then you make a vector a, and initially you have 1 in it. This 1 is for the root. Oh, sorry. Okay, so this is the code. Let me zoom in as well. How do I zoom in? For some reason, zoom is not working. Just a second. Okay. Now it's working. Okay, cool. So basically, what is going on is that first he found out the degree of every node. This actually tells me like how many children in every set we have. Okay. Then what this person is doing is that for a he made a vector a, and in this vector we already have a 1. This 1 is for the root. Okay. Then he just saw that whichever has a degree greater than 0, then push back into this one and then sort this one such a way that the greater value comes in the very starting. Okay. So we have with this, we have this vector now a1, a2, a3, a4 in a sorted manner, and every value in this is nothing but the set of siblings. Okay. All right. So after that we have L equals to a dot size, R equals to n. This is general binary search only. X is the mid value. Now for this X, let's see like what this person is doing. He's doing that for every value in the set, find out ai minus x plus I. This value actually tells me how many values will still be left after spreading. Ai is the number of values in the set. Okay. Plus I is because we wasted I seconds, and this I is the total number of seconds we have. Okay. So ai plus I minus x. This tells me the total number of values which are still left for the infection. Others are done using spreading. Okay, so this is count only. We find the summation of this count for all these values in the set, and then in the end we see that if the size of the complete array plus count is less than equals to x, because x was the total number of infections we could do, count is the total number of infections we need after spreading. Okay, and a dot size are the initial infections we did. If this is possible, then we can say that r is equals to x, because this x can be an answer. That means otherwise we just say l equals to x. In the end we just return print l, and that's it. Okay, can you tell me why you got wrong on 720? What went wrong in your code? That is something I actually even want to see. So maybe we can see like after this code. Is this clear to everyone now? Okay. Okay, do like the stream, guys. I only see like 37 likes, although we have very less viewers today. Okay, cool. Let me also see like what went wrong in my code. Just give me a minute. Okay. Why binary search? That is something like that is something you get in, like we know that for every second we can see like if this is possible or not, then we can actually do like binary search for that. So just my keyboard is again not working. What is happening? Okay, let me see like what went wrong in my code. Okay, I see many people got wrong. I got 221 20th yes, the answer should be 206. That's so. Okay, yeah, I also have the same mistake, and I don't think like it's easy to debug, so I'll just leave this one. Okay, cool. I think everybody is clear with problem C now. Should we try like problem D? Like I know my solution and I'm pretty sure like that is correct, but I'm actually getting a wrong for this like next test case. Okay, so if you see, I actually made some. Oh, my code submission. Why was binary search intuitive in this case? Yes, it was like after you see that for any number of seconds you can actually find this. We are able to like get an intuition that we need to use binary search. Can they be greedy approach? I think there can be a greedy approach, but the greedy I wrote got a wrong answer, so I don't really think like that's worth the time. Did you use CRT, Chinese remainder theorem, and D? No, I did not use Chinese remainder theorem, but I did something like that only. Although like it's a little complex to explain. Also got wrong answer. Like this is how I did problem D, if anyone is interested. But let me just open up the editorial. In the editorial, it literally power of 2 have find x GCD of 2 to the power k minus r. Where is x in this? Okay, it is here. Oh, okay. X plus 2 to the plus to the, yeah, I did the exact same thing. The power k 2 to the power k plus 1. Instead of like subtracting r, I actually added r. If GCD of 2 to, then yeah, exactly. Then else this is r. You exactly using this we will find x mod 230, which is just x exactly 30. I think this one. Let's consider a set of pairwise coprimes. Their LCM is greater than this. That's why x mod LCM equals to x. Let's find x mod each of these integers. That for each I till 23, we can ask GCD of x plus I, x plus LCM plus I. Okay, the query is I LCM plus I, then the GCD is a multiple sum number from us. I don't know. मैप से हो गया ऐसे क्यों भैया? सेकंड क्वेश्चन में अनऑर्डर्ड मैप टीएलई दे रहा है बिकॉज अनऑर्डर्ड मैप एक्चुअली दैट्स स्ट्रेंज. नहीं, अनऑर्डर्ड मैप में तो लाइक no, I don't think like it should be TL. Like even if you have an unordered map, like I don't think you need an unordered map or any map actually. Okay. Okay, I don't think like it's beneficial to do D on the stream only because this is a little different than I did. I actually added R instead of sub. Anyways, I think that's it for the stream then. I did problem ABC stream. If anyone is still confused about any problem, they can just go back into the stream and see. And I think we can end the stream with this one. We also have a contest tomorrow. So we have educational round. Which one? It's 126 and it starts at 8 only and length 2 hours only. So I'll probably come live at 10:30 only. Today I came live at 10:45 because of something. Okay, cool. Okay, I think that's it. Do like the stream, guys, and also comment like if you're liking these streams and if you want like if you see something where I can improve or you want me to add any other contest of any other website, maybe I can do that as well. Okay, cool.